Hello and welcome to my science tutorials. In today's video, we want to look at the second derivative using an implicit differentiation. Before we begin, if you are new to my science tutorials, kindly consider subscribing and turning on the notification button so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So without further ado, let's begin. So we have a problem today and we would like to solve this problem. So the problem is we have y is equal to s squared plus y squared, which is equal to 2y. We have to find the first derivative in terms of x and y. And we also to prove that the second derivative of the function is equal to 1 on 1 minus y raised to the power 3. So we can see that this is an implicit differentiation question, and we will have to find the second derivative, which is what we have over here. We will have to attempt to find the second derivative of this function to be able to prove that the second derivative is equal to what we have over here. So let's go ahead and look at how to approach this question, the various things we need to watch out for so that we can be able to achieve our result or this answer at the end of the problem. So let's go ahead and see how we solve this problem. So we write down solution. Now, if you're new to my science tutorial and you've not watched the implicit differentiation tutorial and how to use the quotient rule, I recommend you check the video description below and you'll find a link to our playlist on implicit differentiation as well as the full tutorial on differentiation so that you'll be able to catch up with us over here. But if you're already an existing member of this platform and you know how to differentiate implicitly, then let's go ahead and look at the solution for this problem. So we have y to be equal to s squared plus y squared, which is equal to what? 2y. So it means we have this function to what? To differentiate implicitly. So I have here, this implies s squared plus y squared is equal to 2y. For me to differentiate this function, I need to apply d dx to the function. So if I do that, it becomes d dx of the function s squared plus y squared to be equal to d dx of 2y. So from here, I can apply the d dx to each of the terms in the bracket individually. So that becomes d dx of x squared plus d dx of y squared to be equal to d dx of what? 2y. So if we differentiate s squared over here, because we are differentiating with respect to x, we get 2x over here, then plus. Now, if you look at this statement over here, we are differentiating with respect to what? X. But the variable we have over here is y squared. So that means we differentiate like we differentiate an x, so it becomes 2y, but then we add dy dx to the differential of the statement we have over here. Now this is equal to, over here we have y again, so if we differentiate 2y, we get what? We get 2, but then we add dy dx to it since we are not differentiating with respect to x over here. So from here I have this statement. Now I would like to group the dy dx terms, the terms with dy dx at one side so that I can be able to find dy dx, which is my first derivative I was told to find in this question. So let's go ahead and look at that. For me to avoid negative, I will maintain the 2x over here. So I have 2x is equal to, then I have this statement over here, which is 2 dy dx. Then I bring this statement to the other side of the equal to sign, and then it now carries what? A negative charge. So I have minus 2y dy dx. From here, I can see that 2x will be equal to, if I factor out dy dx, I'm going to get 2 minus 2y multiplied by dy dx over here. So from here, I can make dy dx the subject by dividing both sides by 2 minus 2y. So I'm going to do that. So 2 minus 2y, 2 minus 2y over here. This gets rid of this. So I have my dy dx 2 be equal to 2x on 2 minus 2y. But know that we have 2 common over here. So if I factor out 2 here, I'm going to have 2x on 2 into bracket 1 minus y over here. This can cancel this. So finally, my dy dx becomes x on 1 minus y as my dy dx. Let's take note of this first differential as we are going to use it in finishing the problem. So from here, we can go ahead and attempt the second differential of this equation. So for the second differential, it means we will have to differentiate the first differential that we already have, dy dx over here, to be able to get what? Our d squared y over the s squared. So this means I would have to apply d dx to 1 over, let me get that from here, x on 1 minus y. So it is x on 1 minus y as my equation for dy dx over here. So this is equal to, now if you look at this, you can realize that we are trying to differentiate a quotient. So from here, we use something we call the quotient rule. The quotient rule. Now, if you don't know what the quotient rule is, I'm going to leave a link to the description of the playlist for quotient rule so that you can go through and understand what we mean by the quotient rule. But if you already know what the quotient rule is, you know that in this case, we say let our u be x, this x over here be u, and then let v be our denominator, which becomes 1 minus what? Y over here. So the quotient rule states that we have our dy dx, okay, which is our differential of this equation, dy squared dx squared, will become what? The quotient rule is what? V du dx minus u dv dx all over v squared. This is the quotient rule. Okay, so for us to find our d squared y ds squared, we need to what? Differentiate these two guys over here. So if I differentiate u, I'm going to get du dx, and that will give me what? If I differentiate x, I get 1. Now if I differentiate this over here, it becomes dv what? Dx to be equal to, if I differentiate 1, I get what? 0. If I differentiate negative y, I get what? Negative dy dx. So from here, I can now do these two substitution into this formula to get my answer. So it means my v is y minus 1 minus y, okay? Then multiplied by my du dx is 1. So I have 1 over here. Then minus my u is x into bracket. My dv dx is what? Negative dy dx. All on what? V squared. My v is 1 minus y. So I have here 1 minus y squared. So from here, I can proceed to write by d squared y over the s squared is equal to 1 multiplied by this will give me 1 minus y, and then minus the negative sign over here multiplied by the negative sign here will give me addition. So I have plus x into bracket dy dx all on what? 1 minus y squared. But we know that our dy dx, okay, which we found in the first case, which is over here, is what? X on 1 minus y. So we know that this is what? X on 1 minus y. If we do that substitution in place of this, we get our d squared y over the x squared to be equal to 1 minus y plus x outside the bracket multiplied by this, which is what? X on 1 minus y, all on 1 minus y squared. This is now equal to 1 minus y plus the x multiplied what we have at the top here to give me what? S squared on 1 minus y, all on 1 minus y squared. So from here, let me try to what? Simplify the numerator before we proceed to solve it with the denominator. So I have here my d squared y over what? The s squared to be equal to, I have my denominator, the LCM for this and this is what? 1 minus y over here. Okay, so we assume this guy has a denominator of 1. So the 1 will go into the LCM, 1 minus y times. Okay, so we use that to multiply this guy over here. It gives me 1 minus y squared, then plus the denominator here, 1 minus y will enter 1 minus y 1 times. So 1 multiplied by s squared will give me what? S squared over here. Then this guy on 1 minus y squared. So this is equal to, if I simplify what I have in here, 1 minus y all squared will give me 1 squared will give me 1, then minus 2y plus y squared, that is if we expand what we have over here, n plus s squared all on 1 minus y, then divided by this guy over here becomes divided by, okay, 1 minus y squared. So from here I can say my dy squared on ds squared is equal to, then I have over here, this guy over here becomes, we have 1 minus 2y plus y squared plus s squared all on 1 minus y multiplied by, if we want to get rid of the division sign, we introduce multiplication and then we reciprocate this guy, so it becomes 1 on 1 minus y squared. Are we okay? So from here, let me get space over here. Okay, so from here we have d squared y on ds squared to be equal to, all this we have at the top multiplied by 1 will still give us the same result. So we have 1 minus 2y plus y squared plus s squared all on the denominator multiplied by this, okay, because the bases are the same and this one has a power of 2, this one has a power of 1. The law of indices, if the bases are the same, you add the exponent. So here it becomes 1 minus y, okay, then 2 plus 1 or 1 plus 2 over here. So it means the y squared on the s squared is going to give me 1 minus 2y plus y squared plus s squared all on 1 minus y raised to the power 3. Now we can see that this is already looking at what we were expected to find. But how do we simplify the top over here to get x, just x on 1 minus y raised to the power 3? Sorry, 1 on 1 minus y raised to the power 3. How do we do that? Now if we take a look at the question, we realize that it said y is equal to s squared plus y squared is equal to 2y, which implies that wherever we see y squared plus s squared, we can replace that by what? 2y. Are we okay? So we know from the question, y squared plus s squared is equal to what? 2y. So it means this guy over here is equal to 2y. So if we substitute that, we do that substitution, we are going to have 1 minus 2y. Then the whole of this guy becomes plus 2y, all on 1 minus y raised to the power cube. So finally, our d squared y on dx squared will be equal to negative 2y plus 2y will give us 0. So we have 1 on 1 minus y raised to the power 3 as required of s. So this is how we do the second derivative or the second differential of an implicit differentiation. We have to note that every step of the process is very, very important. That is, the first differential will be needed for a substitution when you are trying to find the second differential, and you need to look at the product that you'll be getting at the end to know whether you will need to use a quotient rule or the product rule or any of the rules that we use in differentiation for you to be able to get your answer. And also don't forget that the basics such as indices or logarithm may also be needed along the way. So try to open your mind to look at the possibilities and how you can manipulate your result in a correct way to get the answer that is required of you. So thank you so much for watching, and I will see you in the next video. Bye bye.